Alright guys, Coach Goo here and welcome back to another episode of fun-filled, action-packed, flipped Geometry Classroom. Let's get into it today. We're going to be learning about segment proofs today. So look at this page. You see right here, hang on. It says properties of equality at the top. We learned these yesterday or the other day. It says addition property, all these ones. You can only use these, look at this. You can only use these properties with equal signs. That's why a lot of them, at the end of them, it says addition property of equality, division property of equality, transitive property of equality. So now we're going to be learning some new properties of congruence. Oh, I can't grab it. Whoops, gotta get back on that screen sketch. We're going to be using properties of congruence, okay? That means you're going to be using these properties with the congruent sign, and that's different than the equal sign because the congruent sign has a little squiggly on top. Okay, so properties of congruence. Let's get into it. All right, here we go. So I'm going to get on the screen sketch, so follow along and write on your paper as well. So the first one is the reflexive property of congruence. Now, if you remember, the reflexive property with the of equality just says that a number equals itself. So in this situation, this would be for any segment AB, then AB, I'm gonna put the little line over, AB equals itself, or look at me, I messed up already. We're talking about congruence. AB is congruent to AB. It's congruent to itself, okay? Remember, we have to put the line segment symbol over the letters because we're talking about, the shape of the segment. All right, next one, the symmetric property of congruence. If AB is congruent to CD, then CD is congruent to AB. Transitive property. If AB is congruent to CD and CD is congruent to EF, then AB is congruent. Oh, I messed up my sign. AB is congruent to EF. Oh my goodness, that's crazy. AB is congruent to EF. Wow. So we just cut out the middleman. Remember, this is that, if a dog, no. If a cat is really a dog, but a dog is really a giraffe, then the cat is the giraffe. That was this one, okay? So let's go into these bottom ones. Let me scroll it down. So now we've got some definitions. Remember, you can also use definitions, and you're gonna use definitions as reasons in your proofs. So the definition of congruent segments. Segments are, why does this, wow, there's a typo on this. Segments are congruents. It should say congruent. Segments are congruent if and only if they have the same measure. That means if AB is congruent to CD, then the length AB equals CD. Remember, when we're using the equal sign, we're talking about the measure, the length, and we don't need to put the segment symbol over the letters. But when we're talking about the shape, congruence, we're going to make sure we write the symbol over the letters. Okay, and then that means also if AB equals CD, this is talking about the length because I used the equal sign and I didn't use the symbols, then AB is congruent to CD. So it goes both ways. If AB is congruent to CD, then AB equals CD. If AB equals CD, then AB is congruent to CD. All right, now the definition of midpoint. This one should be a review, y'all. The midpoint of a segment divides the segment into two congruent segments. So if M is the midpoint of AB, let's draw ourselves a little picture. A, B. If M is the midpoint of AB, then AM, that's this section, is congruent to MB. That's this section. And what are those symbols that we're going to label to show that they're congruent, the little lines through it.
The little lines through it.
Alright, so make sure you label it like that, because remember, a picture doesn't mean anything until you've labeled it. Alright, let's go on. Now, the postulate. This is also should be a review. The segment addition postulate. We had a whole test over this one, guys. If A, B, and C are collinear, like this picture, that means they lie on the same line. B is between A and C. B is between A and C. That doesn't mean it's the midpoint. It could be, but we know that it's somewhere between A and C. Then AB plus BC equals, what do you, look, AB, wow, I keep, AB plus BC equals, what do you think? It equals AC, the whole thing. AC. AB plus BC equals AC, which is the whole thing. And remember, this one we're talking about the lengths, because we're using the equal sign. You're going to be using these ones today in these examples. So let's go to some examples. Alright guys, let's get started with these examples, starting from number 1. The numbering might be different on mine and yours. Just make sure you're starting on the same one that says the exact same stuff. So make sure yours says that the given is RS equals 1/2 RT, and that you're trying to prove that S is the midpoint of segment RT. Okay, so we want to prove that S is the midpoint of segment RT. The picture looks like it's in the middle, but we don't know. While we're doing these, make sure you always look at your rules, your definitions, the postulates. Look at the things that we've already learned, so that way it can help you find your answers that you're looking for. So here we go. Number 1. So at the top you can see that in blank number 1 it says RS equals 1/2 RT. That is given to us right here, right there. So our reason, we're going to be writing given. All right, number 2. How do we go from RS equals 1/2 RT to 2 RS equals 1 RT? We multiply both sides by 2. And so there we use the multiplication property of equality. All right, next. They're showing that the reason is the segment addition postulate. So if you look at the other page, or look at where you have the segment addition postulate written down, you'll see that it would say that RS plus ST equals RT. That's saying this part right there plus this part, ST, equals the whole thing, RT. Okay? Now, next, how do we go from RS plus ST equals RT to 2RS equals RS plus ST? So, if you look back at step 2, you can see that 2RS equals RT. Right here we have an RT, so we can substitute 2RS in there. So it would say 2RS right here equals RS plus ST. So we use the substitution property of equality. So technically, if you just substituted, it would say RS plus ST. Okay, watch, I'm gonna show you step by step. RS plus ST equals RT. Then if you substituted, it would say RS plus ST equals, remember RT right here, equals 2RS. So we say 2RS. And then they switched it up on you and they just went straight to 2RS equals RS plus ST. So technically there is a symmetric property of equality in there that they kind of skipped. But regardless, you know, you use substitution first, and then you use the symmetric property, and anyways, you ended up right there. So they skipped one, but that's cool. All right, then from step 4 to 5, how do we get from 2RS plus RS plus how do we get from 2RS equals RS plus ST to 1RS equals ST? We subtracted 1RS from both sides. Boom. So we use the subtraction property of equality. right there. All right, next. They're showing that we're going to use the definition of congruent segments. Look at the definition. What does that say? That says if RS equals ST, then segment RS is congruent to segment ST. All right? That's by definition of congruent segments. And then finally, look, they're asking for definition of midpoint. Well, if you look back at the definition of midpoint, it says that if RS is congruent to ST, look, RS right here is congruent to ST right there, then S will be the midpoint. So what we're going to write is S is the midpoint of RT by the definition of midpoint. And we have finished our first geometric proof. Oh my goodness. Give yourself a high five for that one. All right, let's go to number 2, the second example. All right. Ooh, this one's got 8 steps. Oh, baby. So this time we're given that M is the midpoint of Ln. Let's start labeling right away. M is the midpoint of LM. That means of Ln. That means that Lm is congruent to Mn. Okay, we know that by the definition of midpoint. And then they also tell us that N is the midpoint of MO. So that means that I'm gonna use a different color here because we're not sure yet. Mn is congruent to NO, and they want us to show that LM. They want us to show that LM right here is congruent to NO right here. They want us to show that. Now, maybe it seems obvious with a picture and by our labeling, but we need to prove it. That's the whole point of this. So let's kick it off. M is the midpoint of Ln. How do we know that? That's given to us, so given. Now, they say that the reason is going to be the definition of midpoint. What's the definition of midpoint? If you look, it says if M is the midpoint of Ln, then Lm is congruent to Mn. And look, we even labeled that first because we knew. Okay, then how do we go from step 2 to 3? Look, we changed the congruent sign to an equal sign. That's going to be the definition of congruent segments. That's the definition of congruent segments. If segment LM is congruent to segment MN, then LM equals MN. The measure of LM equals the measure of MN. Next, we have a given. So what's the other given that we didn't use? N is the midpoint of MO. All right, then look at that. They're writing segment MN is congruent to segment NO. How do we know that? That is the definition of midpoint. That's by the definition of midpoint. Next, they're using the definition of congruent segments. Look, what is the definition of congruent segments? It says that if segment MN is congruent to segment NO, then the measure of MN equals the measure of NO. All right. Next, you can see that they're using the transitive property of equality. What does that say? Well, look right here. If LM equals MN in step 3, LM equals MN. So I'm going to write it out here too. LM equals MN. Then in step 6, we see that MN equals NO. Then I can just cross the middle one out. Boom! And LM equals NO. So then in this space, we're going to write LM equals NO. Okay, so that's by the transitive property of equality. And then how do we finish it off going from step 7 to step 8? That right there, my friends, is the definition of congruent segments. There you go. It says that if the measure of LM equals the measure of NO, then segment LM is congruent to segment NO. And we have finished another one. Give it a big green check mark. We did it. Woo! All right, and now let's go on to the last one. Example number 3. Not sure what number it is on yours. Maybe it's 3 as well. So this one, it says that Y is the midpoint of XZ. So let's go ahead and label what we know. We know that y, if the y is the midpoint of xz, then xy is congruent to yz. So keep that in the back of your mind. Keep that stowed away right there. Just put it in your pocket. All right, number 1, given. What is a given? It's y is the midpoint of xz. So y is the midpoint of xz. That's a given. All right, next, we're using the definition of midpoint. So what's the definition again? If y is the midpoint of xz, then xy is congruent to yz. All right. Now, how do we go from step 2 to 3? We went from the congruent sign to the equal sign. That's going to be the definition of congruent, that's a squiggly, segments. If xy is congruent to yz, then the measure of xy equals the measure of yz. Now, how do we go from step 3 to step 4? We add xy to both sides, and that would give us 2xy equals xy plus yz. If we added, what did we use? We used the addition property of equality. Good. Next, they're giving us the reason. We're using the segment addition. That's not property, that is postulate. Postulate. What does that say? That says that xy plus yz equals the whole thing, xz. Once again, this part, xy plus yz equals the whole thing. All right. So now from step 5 to 6, we have xy plus yz equals xz, and suddenly we've got 2xy equals xz. How do we do that? Well, if you look back in step 4, you can see that 2xy equals xy plus yz. And then in step 5, we had xy plus yz equals xz. So once again, look, if you write it out, 2xy equals xy plus yz. And in step 5, xy plus yz equals xz. Cross out this middle one. Boom! 2xy equals xz. What is this? That is the transitive property of equality. All right, and then final step 6 to 7. How did we go from 2xy equals xz to 1xy equals half xz? We divided both sides by 2, and that means we use the division property of equality. And we have finished the last example. Let's give ourselves a huge check mark. Boom, we did it! And that is the finish of this video, and I'll see you in the next time. Peace!